plan for the day today. You just have a couple of things to do. In your upcoming, you should see this Newton's first law notes and practice problems. So when you open this up, you see your directions. There should be a couple of attachments. I have the note outline there for you and the first law video. So before you even jump into the video, take a look at the note outline. It's a Google Doc that you are then going to send over to Notability. All right, so share and export, send a copy, and then send that over to Notability. Okay, once you've done that, you should be able to take a look at the first law video. Okay, that will run you through all of the notes on our topic for the day today, which is Newton's first law, which is the law of inertia. Okay, hopefully you've heard that word before. If you've seen any Bill Nye the Science Guy videos, one of the first things they say in that video is inertia is a property of matter, and it's a very important property that you're going to learn about in this video. So, like always, you're going to go through, you are going to fill out both the left-hand side and the right-hand side. Really important that you're practicing answering those questions as you go. You have 2 summary questions to answer today. What is inertia? And don't say property of matter, please. And then the second question is, what does an object's inertia depend on? So go through, answer those. Take a look at the video. I want to then start you out on these practice problems. Okay? So the first question reads, imagine a place in the cosmos, which means somewhere in space in our universe, far from all gravitational and frictional influences. Okay, so this is going to be a place where there are no planets, no stars, no nothing. Okay, and suppose in that place it's you and a rock. Okay, what you need to do is, in this place, you're going to throw that rock. What's going to happen to that rock after you throw it? Is it A, gradually stop, or B, continue in motion in the same direction at a constant speed? So you pick. Okay. I'm going to start you out on this one. The correct answer here is B. It's going to continue in motion in that same direction at a constant speed, because after watching the video, you'll see that because of Newton's first law, which states an object in motion will stay in motion. Okay, and there are no unbalanced forces to stop it. Okay. In this place, since there's no other gravitational force to cause the rock to change its direction, and there's no friction to slow it down, that object will just keep doing what it's doing because of its inertia. Okay, that's what that first law is all about. Okay. The second question says a 2 kilogram object is moving horizontally, so horizontally is this way, with a speed of 4 meters per second. So every second, this object moves 4 meters. Okay, the question is how much net force, okay, so net force, if you remember, is the sum of forces. Okay, so how much net force is required to keep that object moving at that speed and in that direction? Okay, so again, go back to those notes and think about what inertia is, what does it mean about the motion of objects, and how does it relate to force? Okay, I'll start one more with you and then you can do the rest. So we have 2 people, Mac and Tosh, the puns in this one are great, are arguing in the cafeteria. Mac says that if he flings the Jell-O with a greater speed, it will have greater inertia. Okay, so in this case, important, greater speed. He's saying it has more inertia. Tosh argues that inertia is not dependent on speed, but rather on the mass. Okay, what you need to do is figure out who you agree with. So you're going to pick either Mac or Tosh, and you need to explain why. Okay, again, there is one thing, it was a summary question answer, one thing that inertia depends on. Okay, all right, so I'm going to leave you there. Make sure you watch that video, answer the questions as you go.